like that. It's insane. That's an extremely small gap. Fuel to air has to be perfect.
We'll see if it runs. Maybe it will run.
There you go. That's amazing.
That was freaking tiny. You know, they've shown really small V8s on the internet and on YouTube, but they're run by air. I don't consider that an engine.
No, a lot of them are just air.
Just air, and I got this whirling, and this guy's holding the whole thing on his fingertip, and I'm running air on it. I go, that don't mean nothing.
Oh, come on now. I've got my 5-cylinder over there, runs on air. I like it.
But you know what I mean.
Oh, yeah.
It'll take a little while to
Decide
decide it's going to run.
There she goes. Wow, that's a nice sound.
This is a modified Wall 50C engine with 4 carburetors, and it has a special air-cooled head. It has an automatic starter and a cooling system, and it has a little pedal here for the gas. And this has a Kettering ignition system. This is the first engine I built, and this was built in 1997. This is a Wall block 50cc. It is an F-head, which means that the intake valves are in the head and the exhausts are in the block. Very much like Rolls-Royce and Bentley and also Willys did many years ago until they went to an overhead valve system. This also uses a Kettering system. It has oil filtration, full oil pressure, twin carburetors, cooling system, fan, and this was built in 2000. This is a Challenger V8 that was designed in the late 60s. Basically, we think it's 2 walls put together. I built it with air-cooled heads, and it has a special oil pump and water pump on the rear of the engine that's directly driven off the crank. The oil pump will put out 80 pounds oil pressure if you adjust it that way. It does have oil filtering on the side and an oil pressure gauge. This front unit is a water cooling tower. The radiator is down below. It uses 3 carburetors, although the outside 2 only come in at the extreme. And it runs very nicely, and I built this one here in 2001. And it's been running ever since, never taken apart. This one here is another Wall block, based on the Wall block. It's an overhead, has titanium valves, rocker arms are to 70-75, uses an electronic system, a CDI system, has full oil pressure, has filtering built into it with an automatic starter. This is an overhead cam. You can see the cam in there. And the cam is adjusted by buckets, similar to Alpha and Jaguar. Runs 4 carburetors, electronic ignition. And the engine is tilted over at 30 degrees because I used to drive Peugeots and they were tilted over at 30. So I thought I'd do something a little different. Runs real well. That's about it. This is a original wall. This is how they looked originally with a water-cooled head. The engine has since been changed totally in that it has a electric starter. It also has a generator to generate power, which eventually there'll be a sign over here flashing, drawing current from the generator. It has electronic ignition. This one here is unusual, and it has a dry sump oil pump, and it has a high pressure oil pump, and it'll pump 60 pounds oil pressure. This is the gas tank. The cooling system is below the engine, as in all these engines, and this is the oil tank from which the oil is drawn into the high pressure pump that lubricates the rods, journals. Dick Pertell.
Where do you live at, Dick?
I live in Sunnyvale, California, and I've been doing this for probably about 30 years.
What was your profession?
I was a salesman by trade, but I always wrenched on cars, and I tell people if I can do it, anybody can do it. I'm self-taught. Took me a while, but I'm self-taught, and I have a nice shop.
Very good. Thanks, Dick.
Of 3 fire nozzles, just something off the wall, an old pulley. It's all made out of stuff from the junk pile.
And how long did that take you to build?
How what?
When did you build this, Jim?
That's the last thing I built, last year, this year.
Put that microphone down here, you can hear the air coming through there. You can hear the pump.
It's coming out of here.
Okay.
Where's the exhaust? Right here.
Yeah. All right, how about here?
This is a model, a copy of a toy, or either a salesman sample, I don't know which, from about 1840s.
No particular.
I just built it off of a picture,
Okay.
a photograph. And this I bought, I didn't build it. It's a real early model of a steam engine. Probably goes way before the turn of the century.
Where'd you find it?
On eBay,
Yeah.
yeah.
I was going to say, if you machined that, you're right in there.
Well, it's old, you know, it's really way back. But it's amazing the things they could do with what they had to work with.
What would you say the age of that someone built that?
I'd say around 1870.
Yeah.
Yeah, the boiler's been replaced. This is new.
Okay.
The boiler was all rusted away, it was shot. I had to throw it away. But this here, it was on eBay and it was polished so many times
Yeah.
that all the crannies were filled with that white stuff you polish brass
Yeah.
with.
Yeah.
That's why nobody else would buy it, I guess. And it took me 2 or 3 days with a toothbrush and water just scrubbing it.
Clean it away.
Yeah.
Looks good.
But I just put air to it and it ran right away. It was perfectly made. It's really a nice, even though I didn't do it, it's nice, you know.
They all look good. All right, Kenny. Thank you.
And ins, hit and miss. The design is from Philip Duclos, and it was based on a series of magazine articles, and later it was put in a book, The Shop Wisdom of Philip Duclos. My friend Ed Solenberger built this years ago, and it sports a modified piston now using quad O-rings made of Viton. It's a very good runner.
What about this one here?
Now, this is the Coles small hit and miss, sold as a casting set from Coles. Very complete kit, very nice. This one belonged to one of the members of the club here. This is one of Dwight's nice wood boxes it's on. And they redid it, and it runs great. When I got it, it had one collapsed piston ring, which I took out, and I run on one ring, and that's more than enough. It's got all kinds of compression. It's a wonderful runner. This is a little Angel built from Bob Shore's plans. Some use a bronze flywheels that they sell, but these are much smaller, and yet it runs very nice. It's a good runner. This also runs on a Viton O-ring. I just made a new piston for it a couple weeks ago, and it's finally a good runner after many years of messing with it. This is the PM Research vertical steam boiler. I machined this about 5 or 6 years ago. It's all riveted together. The rivets are the hard part of making these boilers, because you've got to make special tools and seat each one, and then you've got to silver solder everything together. But anyhow, this boiler's been fired, and it'll run steam engines in the future, just not at the shows. And this is the PM Research V-twin steam engine. It's got a single control for throttling and reversing. So you can put it in a boat if you have a good enough boiler. It's kind of a nifty thing. Uses Teflon O-rings. Teflon piston rings. And this is the PM Research 2A, A for aluminum. One of my second steam engine that I built years ago. And it's nice and simple, you just can't stop one. And this is a Stewart 10 vertical, 10V. This started out as a marine version, but I bought a bronze flywheel for it and machined it, so I like the big flywheel on it. It's very nice. These are wonderful runners. You'll see a number of these around the show. And if I remember the nomenclature properly, this is a Graham TRV 1A, and I built this quite a while ago. It's a double-acting, two-cylinder, self-starting steam engine, complete with a throttle and reverse gear. The parts are really tiny. It's a kind of a finicky thing to work with, but it normally runs pretty good. And this is a 10cc Jensen that was built from castings. These were produced as ready-made or as casting kits starting 1950. And it was one of the first model airplane engines as a four-stroke. And what's interesting, most of the early four-strokes were all open rocker, but this is completely enclosed like a modern four-stroke glow engine. So it was very far ahead of its time. It didn't sell well because it was expensive, but it's got adjustable points here for the ignition. It was a spark ignition engine. It ran on straight gasoline. It runs on straight gasoline and has a total loss oiling system like an early motorcycle. So this is a 1/8 scale Ryder Ericsson hot air engine. It was used to pump water, mostly because it has to pump water to run. The hot cylinder is under the bottom, the cool cylinder is on top. It's a type of Stirling engine, and I have it recycling the same water, so the water gets pretty hot after a while. But they pump water through this. There's a water jacket here to keep the upper cylinder cooler than the lower one. And since they had to pump water through that, it was a natural just to keep pumping it somewhere like upstairs in a building or whatever, or up in a water tower. These next two engines were made by a fellow named Andre Zygmunt in Arizona, very talented machinist. This one is another Duclos design, like the odds and ends engine, also built just from plans in the book. and it's a flame eater. The type of what they call a vacuum engine. As the piston goes down, flame is drawn into the cylinder, the valve closes, the gas is cool, it creates a vacuum, it draws the piston back up, and then the cycle is repeated. So it actually eats flame. Some people call it a flame liquor. Andre's other nice engine here is a 6-cylinder, which is also another Philip Duclos design. I've got 3 Philip Duclos engines on the tables today. This is what Duclos called his 6-cycle oddball engine. And it's a 6-cycle instead of a 4-cycle, so it takes 3 revolutions to fire each time. Plus it has the hit-miss governor. So this one runs on a vapor carburetor with mostly successful results, and it uses a buzz coil for ignition. This last engine here, this was made by Roland, a fellow named Roland. They sold these as casting kits or as finished engines. It's called a loyal cycle engine, and what it is, it's an open frame 2-stroke. So, and it has a spring-loaded contact point, which acts as a ignition-style governor. So it's a hit-and-miss engine if it runs fast enough. It also uses a vapor setup of this mason jar here. A very simple engine, and it's a little bit finicky.
What did you do for a career? What was your occupation there?
My last career was as a laboratory technician.
The reason I ask is so many people here are not, they're not machinists by trade.
Right. No, I was just a lifelong tinkerer, and this seemed like a natural thing to get into about eight years or so ago.
All right. Tim Horn, another Bay Area engine modeler member.
Okay, this was my first. That's the Stewart V, a vertical V10, and it took me a long time to do it because at that time I had only a very small lathe and I couldn't even machine the flywheel.
Yeah.
Eventually I got a bigger lathe and I was able to finish it. This one is a PMR, that means I built that one and finished it in 2006, and it's from castings, but there's almost everything else has to be machined. Like on the damasking here, for example, you do that with a. I think I did that with the milling machine, and this one here is completely built from bar stock. No castings on that, and that was fun making it. That's a model that was designed by Rudy Kohout. And there's another one here that is finished in 04, and that's from PM Research, PMR. And now you can get this in double cylinder. And that's fun. I've got this. I have the castings. I just haven't had time to make it. That's a little dynamo generator. I intend to incorporate it. Some of it, make a little powerhouse with wires, and looking for a voltmeter small enough to operate that. And these are little toys I build. They actually work, but they are a little tiny. The design is poor. I only discovered that afterwards, and I wasn't going to do any correcting. But if you have a look at the screws, they're tiny little things that you have to make.
And did you make that radio?
No, that's Jim Ball.
Right.
He made that, yeah.
And over here?
Here is the beginning of a machine shop. This is a grindstone. here for sharpening tools, lathe tools perhaps. This is a shaper. Shaper is a outmoded machine now. It's hardly ever used, except now they go to these milling machines. But the shaper is a fun machine because you can do a lot of things that you cannot do with anything else. For example, cutting an inside of a you know, the square slot for the. That's just an idea, and it actually operates and works just like the big one. I have a full scale one, 7.5 inches.
Was that a kit?
This was a kit from PMR. And this is also a kit from PMR. And this is obviously a lathe. And it can, supposedly, the original machine, which is 12 times the size of this, it is made to be able to cut gears. But this little model, of course, doesn't have all those features. Now this is a press, yeah, press. And you can adjust the different sizes here. And it's a very useful machine even today when you need to press on some bearings or something like that.
And what's your profession, Carl?
Well, right now I'm a watchmaker, but I was an engineer for General Electric Company for a few years.
Okay. And now you're a watchmaker?
Yeah.
Where'd you get that skill?
From my father. He was a watchmaker from the, let's see, he started his watchmaking career when he was 12.
Okay.
And he went through the apprenticeship, you know. And
so look at that. I think some of that skills transferred to your machine shop skills, your miniature machine shop.
I would have to make a note of this fellow here. My daughter is the one that made the overalls for him. That's one of the toys, you know.
Yeah, right. Action figure.
Action figure, yes.
All right. Okay, we're ready to go.
The Ford Model A, I started about 10 years ago, at least. And I ran into a significant problem in getting the skew gears between the crankshaft and the distributor.
Was that a kit?
No,
a casting kit?
No, it's not. There are no castings in it. There are no castings in any of these here.
Okay, and what about the offie here?
The offie, this is pretty much straight off of what's his name's book.
Is it Bob Shore?
No, it's not Bob Shore. I can't think of his name right now.
Okay. And how long did this one take you?
It took about a year.
Really?
Yeah. The time it takes to build an engine depends mainly on how strongly you want to finish it.
Yeah. How much dedication you have.
Yeah. That rotary over here, that took about 9 months.
Really?
Yeah.
Yeah. There's some dedication.
And this one, I started to build it before Whittle actually had finished the engine, and he was sending me handwritten notes from England on the parts that he knew I had to finish yet.
Is that an English design or is it
It's his design. He's an aircraft designer.
about here, Lou?
This one just stopped. I think I'm out of.
Overheated. This is really hot back there.
Yeah. Well, it's out of fuel.
How about this one here?
This one?
Yeah.
Somebody gave me the plans for it, and I said, "Gee, that looks like a fun engine to build." If I had to do it over again, I wouldn't build it as a glow plug engine. I'd put spark plugs in it. And I'm still debating whether I want to put spark plugs in it or not.
Oh, so just some glow plugs on there? Or?
These are just glow plugs, yeah.
Yeah. I mean, you had that for a while?
What a while, yeah.
Looks like it's been there.
Yeah, this goes back about 10 years.
And how about here?
This I've had about 3 years.
And what is there a name for that engine?
No, I'm trying to think of the name of the designer.
And what would you call that? Heat?
It's a Stirling engine. It's a heat engine.
Okay.
Yeah.
Twin cylinder.
One cylinder.
Oh, okay.
This is the displacement cylinder.
Okay, yeah.
And this is the power cylinder.
And this was your radial?
It sort of works, yeah. It's a 7-cylinder radial, and the general design is that of the right the engine that Lindbergh used to fly over the.
Oh, okay. Atlantic?
Lindbergh's was a 9-cylinder, but this is sort of the same design, but only 7 cylinders.
Very good. Okay.
All right.
All right, now Lou, what was your profession?
I'm a chemist, an analytical chemist.
Okay, and then how long was it till you got into this type of?
Oh, I've been in modeling for a long time. Back to control line and.
Control line planes.
Yeah, and even the free flight planes that used the little driven piston for the shutoff, for the fuel shutoff.
Well, it's important that in the club it's unique where most people are not. They're garage machinists, or they've taken on the machinist craft because they wanted to, versus being a machinist by trade.
Yeah.
That's what's unique, I think.
No, I came in learning an awful lot and generating a lot of scrap.
Okay. that's the way it usually goes, but there's no such thing as a mistake if you learn something by it.
That's right.
Yeah.
Never do that again.
All right, Lou.
Well, this is a Kiwi that I built probably 25 years ago. My experience was just a farm kid using simple tools, welder and a drill press, but years later I decided to buy a small lathe. It was a Craftsman 10-inch, and this was built totally on a Craftsman 10-inch lathe. It took probably a better part of a year of my spare time. You learn your skills as you go along. I don't say that there's anything extraordinary about the engine. It was just a great first project for me, and it runs reasonably well. Carburetion's always a problem on these engines. Not much else to tell you. It's got a water pump and just a canister to hold water. It's a gravity feed to the main bearings, and a sump pump that's built into the back of the motor.
Okay, how Put this in your hand.
Oh, okay.
Show me that.
This is a home-built little vise that I built. I made them for Christmas presents for family members, and so I kept one for myself. It's basically made out of several pieces and silver soldered together.
Is that your own design?
Yes, it's my own design. Of course, I try to copy existing vices. I use it as a paperweight.
Yeah.
So that's the size of it.
Cool. And how about over here?
Typical hit and miss.
Hey, you guys didn't see me serve my apprenticeship, did you?
Started building this when I purchased a jet mill, so I had a little more capacity so that I could actually machine the castings for the kit.
And is this a kit?
Yes, it's a kit that I purchased probably 15, 20 years ago. It's called the Hired Hand. It's a exact model of the original that was built for farm use back in 1900. It's a great easy runner.
What would a kit like this typically cost?
I don't know what the current prices are, but I would suspect upwards of maybe 500.
Okay.
But it's a great kit for anyone that wants to build a hit and miss.
Okay.
I highly recommend it.
How about here?
This one is a sea lion that I purchased probably 25 years ago and realized I didn't have the skill to build it. So in the last few years, I've just started putting this one together. It's still in development, but I've got most of all the machining completed. It is overhead cam. I modified the original kit to have belt drive and overhead cam. Hopefully it'll run.
Yeah. And then when you went to make that cam, you got your cam.
Yeah, the cam was designed to be built modular, one piece at a time and put on a shaft, but I decided to build my own cam grinder so I could make the cam in all one piece. And this is the result of my cam grinder development.
So this is your invention?
Yes. A friend of mine started me on it when he gave me this heavy sliding base. And that gave me the emphasis to go ahead and build a cam grinder. It's a sliding table, which works real nice for grinding the cam.
You showed me yesterday how cams were degreed here.
Yeah, it's the master cam is probably the most crucial part of a cam grinder, because how you make your master cam is dependent on the results you're going to get in the product that you grind. This grinder will only produce what the master cam is cut to produce. It has a rocking table. Nothing extraordinary about a rocking table. It's micrometer adjusted for grinding. It's got a little 12-volt motor that's inexpensive. It runs at about 60 revolutions a minute, and so it's battery operated, that part. Of course, I use the good old Harbor Freight grinder, which you can use any grinder you can conceive to fit on your grinder. The grinding head runs about 3 to 4,000 at idle, but when it's grinding it slows down considerably. But it takes about a morning or a half a day to grind a cam on this unit.
Very good, Bob.
I made that one, I don't know how many years ago, probably 15 years ago.
Diesel, and then it's just like runs off a glow plug.
Yeah, it runs on ether and oil.
Yeah.
And you can adjust the compression by turning this.
Okay.
It's a typical model airplane style engine, really. And this one, of course, is an English engine by Westbury, and it's been around since the early 50s.
Sea Lion?
Sea Lion, right. And pretty straightforward project, really.
And this was your second to this?
No, I've got actually 4 engines that aren't here that I built. So I built, my first engine was an English engine. In fact, if you look, well, the first engine I built's over there. It's a that red-headed engine.
Oh, yeah.
I built that one. I built that when I was 17 years old, which was a few years ago now.
For all of us, yeah.
And that's actually an English engine as well, as is this one. This one, that's a 4-cylinder over.
Was this a casting?
Yeah, it's a casting kit.
Okay.
Comes out of England, and that's been around since the early 50s. That casting kit.
That's good.
And it's not a real difficult engine to build. It's difficult enough, mind you.
Okay.
And then there's this one here. This is Jerry Hall's engine. It's all made out of bar stock, except for the exhaust manifolds and the intake manifold. And the rest of it is all bar stock.
And how long did this one take you to build?
That is only 4 cylinders, and it took me about 3 years making that thing. It's a lot of work in that engine. And it's got a radiator in itself is a big project, which I'd never really built. This is my first attempt at a radiator, and it didn't pan out very well at all. It's way too small and doesn't work well at all.
Then what about the radial?
Yeah, this is a Forrest Edwards engine. It was built from plans that he sold. I modified it based on a picture in Strictly IC.
You're good.
Okay, and I modified the best I could to this. The picture in the Strictly IC, it was on the cover of the Strictly IC, and kind of made it look a little bit neater, I thought.
Yeah.
Paul Knapp actually has that particular engine now, and it's 5 cylinders. It has an oil pump. It has an oil rings in it. This also has oil rings in it, and it has an oil pump and water pump. And this is a nice little running engine.
Is this one, is any part of this?
This is all made out of bar stock. No castings for it. Just a set of drawings.
Beautiful.
And it's quite a bit of work. It's a nice little engine. It originally was glow plug, and I modified it to be a spark engine. And this is a points ignition back here, just as that one over there is a point ignition. This one here's got a Hall effect ignition, electronic ignition. Then this engine here is the last engine I built. This comes from Sweden, the castings do. And it's a 9-cylinder radial engine, of a copy of a Wright J5. It's got electronic ignition on it as well. It was a pretty nice project. Castings are extremely good. I had trouble getting it to run. I had to make quite a few major changes to make it run. And it was all back on the carburation side. It had a lot of excess volume in the intake system, and as a result, I didn't have any suction on the carburetor when you pull it through. I couldn't feel any suction at all. Plus, the carburetor was mounted vertically, and when you primed it, the fuel all ran out the bottom. The carburetor is now in horizontal, and I reduced the volume in the manifold system. And also, there's a impeller in there that flings mixes up the fuel and sends it around to the cylinders. I made that bigger in diameter, and also more blades on it. And it really works great now. Really a nice project. The cylinders on it weren't very scale, which I changed that to a picture I had on the real Wright J5 engine. And it's more scale than the original engine. The original engine had 3 rods that went through the head into the case.
Okay.
They're steel rods, and this whole thing is aluminum. So you get quite a differential in expansion, with the heat of the engine running. So I didn't like that, so this is more like the real engine anyway.
Here you are on the chest stand.
Yeah, well, yeah, this is just a stand, but there's a. Oh yeah, that's right. That is the test stand, right?
Yeah.
It's just an old workbench. I bolted it on and ran it. There's the that's the ignition system back there. So that's the same system I use on all these engines.
How about here?
And this one here is a 1/6 scale Pratt & Whitney, and the prop is also scale. It's a variable pitch prop. So, and this is designed by us. It's a Pratt & Whitney, copy of Pratt & Whitney 1/6 size. The engine was designed by a guy in Australia, but the castings were made by a guy in Utah. And it is a very difficult engine to build. It's too small for one thing. That's quarter size. This is 1/6 size. The quarter scale Pratt & Whitney's over there. You can see the big difference.
Yeah.
And but it started rather easily. I was surprised compared to the right. I had to make a lot of mods to the right to make it work. But they both run good. And this one runs really nice.
Now what was your profession?
Well, by trade, I'm an engineer.
Okay.
So, but I've been around machinery all my life. That's how I picked this stuff up.
Yeah.
So
most people have, but a lot of what's unique in the club is the number of people that weren't a machinist by trade.
I know. Yeah, that's right. Yeah, we got a doctor in our group, which is a good. He makes really nice stuff too.
Yeah.
Of course, he's a surgeon, so he's good with his hands.
Yeah, that's right.
So,
Don't want to be ruining those hands either.
Yeah.
Okay. Yeah.
Are we talking? Okay. Basically, this is my work in progress right now. My latest engine I'm building. It's a 4-cylinder. Originally designed as a 6-cylinder, but I'm cutting it down to 4. It was designed by Randall Cox, who's a machinist out in Wyoming right now. And so most of it is all built out of stock. There's no castings involved. For the cylinders and the head, you can start with just a standard rod and kind of clean it up to basic dimensions on the outside. And from there, you have to do all the machining in this stuff, all the additions onto this thing. So the pistons and the connecting rods are all aluminum. The cylinders, and this is cast iron. The connecting rod is kind of, or the crankshaft is very interesting. It's all made out of dowel pins and key stock that you put together, and it's clamped together by the little bolts in here. The key stock is slotted to provide a clamping force. The timing is by chain, which is a commercial bot. I did not buy machine that. So that's about it. Open crankshaft. Everything's going to be open that you can see. All the rockers and the valve lifters and all that's going to be all open. This had originally a unique distributor called a barb hole type distributor. However, I'm going to change it over to a standard rotary type distributor with that's going to, and it will have a CDI ignition system onto it too.
How about your electric motor here?
Okay, the electric motor is just a novelty type thing. I was messing around with it. One time I saw a picture of it in a magazine or someplace and thought it'd be kind of interesting to build. I was originally going to design the coils and all that stuff, and I was playing with it for quite a few years, but I tore apart a couple of old woofer speakers and I saw the coils in there. I said, aha, there's where my coils are coming from. So I finally jury-rigged it and kind of running it. It's running on a 12-volt battery. The switching is through a micro switches run off of the little cams. The white Teflon cams are what's turning on the micro switches. I can't run it very long because the coils get too hot. I may eventually someday put a little fan on it, but right now just don't run it for very long. This little engine was my father's engine. I think he bought it. It's just a toy engine, pretty much an antique. It does run, but it's so worn out that it leaks a lot and it doesn't run very well.
That was your dad?
Yeah, my dad. He didn't make it. I think he just bought it. This is a steam plant that I put together. Most of the kits are from PM Research. In fact, in their catalog, they basically have this set up here. This little yellow and blue engine is a little Cathy. This is a vertical, the little Cathy is a vertical mill engine. This one here is a horizontal mill engine. And this is a basic wobbler engine. The wobbler was never used for anything that I know of commercially in full scale. The two mill engines were used for running mills, both like sawmills and grain mills and stuff like that. They probably took over from the water wheel type drive systems.
And you
Eventually,
threaded all this pipe?
the pipe is all threaded. The fittings themselves I bought, which are available through PM Research also. It's quite a plug for PM Research, huh? So,
Steam engine here.
okay, this is a Shea locomotive that was designed, and all the castings were built by a fellow in Gardnerville, Nevada, Ken Schroeder. Again, this is a 1.5 inch to 1 foot scale Shea. Shays are one of the three geared type locomotives. The other two, one of them is called a Heisler and the other one is a Climax. These are primarily used for logging and mining. They are very slow, powerful engines. They can haul a lot of logs, a lot of mine cars. They also, some of them were run on narrow gauge railroads. Like I say, they were powerful and very slow. They were not used for either passenger or freight trains because they were just basically too slow.
What was your profession?
My profession, I was a mechanical designer, or actually a non-degreed engineer, as I ended up working. Started as a draftsman and worked my way up.
So when did you pick up this craft?
I picked up this craft at actually when I was just as I was going to retire about 12 years ago.
Okay. Because so many people here are not machinists by trade.
No, I'm not a machinist. My dad was a self-taught machinist.
Okay.
He worked as a maintenance machinist in a furniture factory back east.
Okay.
And he had a small machine shop.
Okay.
And I used to watch him a lot. I never really learned from him how to actually operate the machines.
Yeah.
So when I learned it, and that's when I bought this little lathe to learn on. And I also bought like a correspondence course on running lathes and mills and stuff like that through the Gunsmithing Institute. They do a lot of machining. And so then I graduated up to a full-size lathe and milling machine. which most of the work is done on the big size stuff.
Thank you, Rick. Right now, go ahead.
Okay, the locomotive that you're looking at right now is a live steam locomotive built to approximately 1.5 inches to the foot scale, runs on track that's 7.5 inches wide. It took me about 3 years to build this after I'd retired. The locomotive alone, without any water in it, weighs about 375 pounds. The tender is about 135 pounds with it, without water or fuel in it, or without me on top of it, because that's where I ride when I operate the locomotive. The locomotive has to be operated just like a full-size steam locomotive. It has all the same basic controls. You have to use the throttle to control its speed. The reverse lever, or what they used to call a Johnson bar, is the reverse. You have to keep after and control the fire. You have to watch the water level in the boiler and make the proper adjustments to maintain that level of water for safety and to prolong the life of the locomotive. With myself on board, it'll pull 2 people up a 3% grade. On the level, it'll probably pull 2 cars loaded with about 6 people without any problem whatsoever.
Historically, you were an engineer yourself?
Yeah, okay. I was fortunate enough one point in my life that I got an introduction to work on a full-size railroad, the California Western, that ran from the Fort Bragg Lumber Company, or the Union Lumber Company in Fort Bragg, California, to the junction with the Northwestern Pacific in Willits, California, where we interchanged our freight. My regular job, once I got enough seniority and so forth to become the engineer, my regular job was engineer on the night freight. During the summer, we ran the Super Skunk, which was a steam passenger train, and I would always bid that in as a fireman, and the fellow that would bid it in as engineer, he liked to take 2 or 3 days a week off, and I always made sure that I was working on the days he would go off, and then I could run the steam train. So I worked for the railroad about 5 years, and then the Arab oil embargo killed the lumber business, and because my job was on the night freight, there was little freight going out, and the last month that I was on the railroad, I worked 4 days. But you can consider that the night freight, or the freight job, was a 7-day-a-week job. It was never called on Sunday night, but it was called 6 days a week. You went to work at 4:30 in the afternoon. If you were fortunate, you'd get back at 6:30 the next morning, give or take a little bit. So you could figure on about 11.5 to 12 hours of run time. So it was not really a good family job, so it wasn't. I left it pretty easily, but I do have the service letter that says I'm a qualified locomotive engineer in steam and diesel, yard, freight, and passenger service. Oh yeah, I started out making patterns and lost wax castings for the model railroad industry. When I got out of the deal that they called the Army, you know, a group of neighbors have selected you. So I was selected and spent 2 years in the Army. When I came out, I established a company called Precision Miniatures, which specialized in castings, lost wax castings, pattern work, and the development of models for the model railroad industry. And all of the things I did were 1/4 inch to the foot scale, what they call O gauge. Then I taught school for my wife's family decided they wanted their son-in-law to make a regular living, so I started teaching school. Taught school for 17 years. Went to work on the railroad. When I left the railroad, I went to work for a small brass and aluminum foundry in Palo Alto, set up a machine shop and a pattern shop for them, did machine work, trained a couple of people to work in the shop, did pattern work on that. From there, I went to Xerox Diablo in the time when they were making daisy wheel printers, and I was in the print wheel technology group and set up a engraving system. There was a 4-axis CNC to make the molds for the daisy wheels. I left them, and I had a chance to buy a business of my own, and for 10 years I specialized in the removal of broken taps, drills, pins, and studs. The smallest tap I took out was a quad O 120. The biggest one I ever took out was about 1.5 inches. After that, I retired and started building model railroads for real. That's when I built most of the running gear for a friend of mine for a 482, and after that, I got busy and built my own locomotive.
This is a piece for the bell, actually?
Oh, that's left over from my days of making lost wax castings. My son, with his machine shop, he wants to learn how to make those castings, and so I've started to rebuild the patterns for the bell that I have on my locomotive, and I have still a few more parts to make, and the piece that he's holding is most of the machine work. There has to be some holes drilled in it, and then that'll be a pattern for one of the molds for making the bell.
Sounds like an old some of these things are a lot more complicated. They don't sound right. Yeah. Because you can put this really retarded ignition.
Doesn't run good retarded, but it sounds good. Yeah, it sounds good.
That's been sold, and I went to one of these shows about 10 years ago. That one right there.
Yeah, I saw that one.
I had him start it for me. I'm like, oh, that sounds so good. These V8s, they're 1,000 times more complicated, but they, You seem to have changed self-sustaining here.
Hey, finally, finally got some good air. Had some good oil, huh?
No, just the above. Oh, see, I'm missing a nut from somewhere.